Hi, welcome to my channel. In the previous video, we discussed about the linear support vector machine, classification, and soft margin classification, soft margin support vector machine classification. Okay, classification. So that means support vector machine classification is it can perform the classification as well as regression. It can be applied for the classification as well as a regression. So here the classification is done by the help of two things. That means linear classification, and second thing is nonlinear classification. So, or more, the support vector machine classification is done in two ways. One is a linear classification, nonlinear classification. So, when we are going to apply linear classification, if the data set is linearly separable, then we are going to apply the concept called as a linear classification. If the data set not separable by the linear equation, then we are going to apply nonlinear classification. So in the linear classification, there are two approaches are there. One is a hard margin classification, and soft margin classification. There are two techniques are there. Soft margin classification. These techniques are discussed in the previous videos. Please go through and watch those things and okay. Now in this video we are going to discuss about the SVM support vector machine classification. So that is a nonlinear classification. Okay, here although the linear support vector machine classifiers are efficient and work surprisingly well in all the cases, many datasets are not even close to the being linearly separable. So one approach is to handle the nonlinear datasets. And the nonlinear datasets is add the more features such as polynomial features. That means so for example, some data points are not separable using the linear equation. At that time, we are going to add a new feature based on the existing feature. Simply that feature is called as a polynomial features. Okay. So like based on that one, we are going to classify the things is simply called as a nonlinear support vector machine classification. So in some cases, this can be result in a linearly separable data set. Okay now. So for example here, like the data points are positive points. The data sets are positive points. Okay, and the data sets are positive points, and some points are negative points. So at this case, we are not able to classify the data into two parts. Okay, that is positive points or negative points. So at that time we are going to apply concept called as a nonlinear classification. Okay now, so we can classify the with the help of nonlinear fashion. Okay, on this data set. Okay, simply this is called as a nonlinear classification. So here one more technique is called as a, suppose we are having the only one data set. See the figure here. So it contains only x1 feature only. Here it contains only x1 feature only, x1 only. So the data points are -4, -3, -2, -1, 1, and -2, 3, and 4. They are the different points are there. The data points, the class labels are blue color, and blue colors here are squares, and all the remaining points are triangles only, or green color points. Okay. Now with the help of linear equation, we cannot separate these classes separately. Is a square and rectangle, square and triangles. It is not possible to classify these data points using the linear model. So at that time, we are going to create one more data point that is called as a we are creating the one data point with the help of whole data point x2 equal to x1 square. The resultant 2D data set is properly a linearly separable. For example, here x1 contains x1 x2 equal to x1 square. Okay now, so the x1 points are -4, -3, -2, -1, 0, 1, 2, 3, 4. These are the actual data points. Based on the actual data points, we are going to draw the create a new feature based on the x1 square. Okay, that is x2 equal to x1 square. So x2 new points are 16, 9 and 4, 1, 0, 1, 4, 9 and 16. So based on these two features, if you draw the graph between the x1 and x2 features, x1 and x2 features, okay. So all the squares are and on one hand on one side, and all the green points are one side. Okay, so with the help of the dotted thick lines, red line, this is called a decision function. This decision function is exactly classified data into two parts. So this all the points above are called as the thick blue color, and all the points below are called as green color points. Okay, like that we are going to apply type of one technique that is called as a nonlinear class classification. That means for the single feature, if you are not unable to classify the data into two parts, at that time we are going to create a new feature based on the existing feature. Then if you draw the graph between these 2 points and some line, that line equation is are linearly, the data points are linearly separable. Okay, simply this is called as a nonlinear class classification. So here we are going to use the scikit-learn to classify the data points. So we are going to create one pipeline that contains a polynomial feature transformer, okay, then standard scalar, then linear support vector class classification. So here what the steps are: first of all, you have to convert the linear for the given data points. For suppose we are having the only one feature, then create the new feature based on the existing feature, that is x2 equal to x1 square. This is called as a polynomial feature transformer. Okay, then apply standard scalar, then apply linear support vector class classification. All these steps are called as a one pipeline. Okay, that pipeline contains a sequence of steps you have to carry forward one by one. This is called as a pipeline. Okay. Now here our dataset is nothing but a moon's dataset. It's a tied dataset for binary class classification. Which the points are in the are shaped as a half moon. So that is a two interleaving the half circles. Okay. Now we are going to find out that write the code for this model. Okay. Here we are going to generate the code for our dataset. So first of all, we are going to make use of the make moon dataset from the scikit-learn dot datasets. We are going to import the make moons, and from the scikit-learn dot pipeline we are going to import the pipeline, and from the scikit-learn dot preprocessing we are importing the polynomial features. Then we are going to divide the data into x comma y, that is x nothing but features and y nothing but corresponding class labels. Make moons of n number of samples equal to 100, the noise equal to 0.15. So based on there are 100 points are there, and the noise points is 0.15. That 100 points with the noise 0.15, we are creating the data set that look like a half moon. So then we are going to create a model called as a polynomial SVM class classifier. It is equal to polynomial pipeline. The pipeline is nothing but carry the different steps sequentially. The first step is you have to create the polynomial features. So polynomial features degree equal to 3, and then this is the first step. Then we are going to apply the second step is called as a scalar. Then that is called as a standard scalar, that is z equal to x minus mu by sigma. This step is going to apply on all the data points. Then apply the linear class classification, linear SVC, linear support vector class classification. For that we are going to give the C equal to 10 and loss equal to hinge loss. These two parameters, hyperparameters, are going to be changed according to our requirement. Then our model is going to be ready. So based on this model, we are going to train the model. Okay, with the help of x and y. So that means polynomial polynomial underscore SVM underscore classification dot fit function. For the fit function, we are providing the class label and features on the corresponding class label. If you execute this one, you are going to get the output to look like here. Okay, so the model is contains 100 data points. It contains 100 data points with a noise of 0.15. Then the points are look like blue color and the green color, like squares and triangle classes. Now our aim is we have to classify the data points. Blue triangles on separate class and green colors are become triangles are one separate class. So this is done by using the with help of nonlinear class classification, with help of polynomial, with help of polynomial features. So this, after creating a polynomial features, we are applying the standard scalar, then apply the linear model, linear SVC class classification. Okay, like that we are going to convert classify our nonlinear data into linear fashion. Okay, simply this is called as a nonlinear class classification. Thank you for watching our video. If you like the video, please subscribe. Thank you.